Hello, men and women of science. This is Mr. Cochran here to talk about moles. No, not these little creatures that burrow in the ground or a spot on your chin that you got to shave around. It's the kind of mole we use in chemistry to work with amounts of matter. So let's get started. What's in a mole? Well, a mole is a counting unit that we use in chemistry for quantifying matter. Much like a dozen is always 12 of something, a mole is always 6.02 times 10 to the 23rd of something. The somethings we're talking about in chemistry are usually atoms or molecules. Molecules are particles that are made up of more than one atom, like water is made up of 2 atoms of hydrogen and 1 atom of oxygen. We could also count a mole of donuts, but a mole of donuts would bury the planet several thousand feet deep in donuts, and we don't need a number that big for donuts. Why do we need a number that big for atoms and molecules? Because they're so incredibly tiny, it takes that many to have a significant amount to work with. So how do we measure out a mole? Well, we generally do it on a balance by measuring grams. A mole is the atomic mass in grams, and we find the atomic mass on the periodic table, and you'll want to have a periodic table available to you as you work through this video. So why don't you pause and go grab one if you don't have one right now, or you can find one in the back cover of your textbook. If you look at atomic number 6, carbon, you'll see that it has a decimal number below it equal to 12.011. In our chemistry classes, we're going to round our masses to the second decimal place. So always look at the second decimal place and round to that when you're recording masses. The problems in this video will use masses that are rounded to the second decimal place, as do most of your worksheets. So let's get started. Let's look at how to convert from moles to particles or particles to moles. In order to do that, we need conversion factors. In order to write conversion factors, we need to know what's equal to what. In this case, 1 mole is 6 times 10 to the 23rd atoms or molecules. That gives us a conversion factor of 1 mole over 6 times 10 to the 23rd particles, which would be useful for converting from particles to moles, or 6 times 10 to the 23rd particles per mole, which would be useful for converting from moles to particles, such as atoms or molecules. Let's go ahead then and first look at how to convert from moles to atoms. Here's a typical problem that you might see in chemistry class. How many atoms are in 0.0275 moles of iron? When you look at these problems, you want to really pay attention what you're converting from and what you're trying to achieve at the end of the problem. In this case, we're converting from moles of iron to atoms of iron. If we're going to do that again, we need to know how many atoms are in a mole. Good old Avogadro's number there, 6 times 10 to the 23rd. When you start this problem, you want to write down what you're converting from, in this case moles, and then you want to choose a conversion factor that factors out moles and gives us atoms. And we have a couple choices here, and you can see that the second one, if I use that, allows moles to factor out. Moles divided by moles factors out, and we would get atoms. So we're going to grab a calculator now, and again, if you don't have a calculator, grab a calculator and have it with you, and multiply 0.0275 times 6.02 times 10 to the 23rd. When you enter times 10 to the 23rd in your calculator, it's good to use, if you have it, an EXP button or an EE button to signify 10 to the 23rd. When you enter that in and multiply it out, you should get 1.6555 times 10 to the 22 atoms of iron, but you can see that our starting value has only 3 significant figures, and that limits our answer to only 3 significant figures. So I'm going to look at the third significant figure from the left, look one to the right, it's 5 or greater, and so I'm going to round 5 up to 6, so I'd have 1.66 times 10 to the 22nd atoms of iron. And like all good chemistry calculations, you should circle your answer and celebrate because you have it right. All right, so to convert from moles to particles, multiply by 6 times 10 to the 23rd particles per mole. That would be atoms per mole, or it would be molecules per mole. Now let's try converting atoms to moles. Here's another problem. How many moles are in 3.4 times 10 to the 22 atoms of carbon? In this case, again, I want to look at what I'm converting from and to. I'm converting from atoms to moles, so I need to know the atom to mole ratio, and I might write that down for myself. I'm going to start by writing down what I'm converting from, and then I need to choose a conversion factor that factors out atoms this time and gives me moles. So the best choice here is the first one that we see, because atoms will factor out and I'm left with moles, which is the goal in this problem. Now I'm going to grab a calculator, and this time instead of multiplying by 6 times 10 to the 23rd, you can see I'm going to divide by 6 times 10 to the 23rd. And this is where that EE button will come in very handy, because I don't want to type in my calculator times 10 to the 23 unless I put this in parentheses. If I have an EE or an EXP button, I don't need to do that. So when 3.4 times 10 to the 22 is divided by 6 times 10 to the 23rd, you should get 0.05647 moles of carbon. Again, if I look at my starting value, it has only 2 significant figures, so I need to round my answer to 2 significant figures. In this case, that's the 6. I look one to the right, it's a 4, and so the 6 stays the same, and my answer is 0.056 moles of carbon. So to convert from particles to moles, I'm going to multiply by 1 mole over 6 times 10 to the 23rd particles. To convert from atoms to moles, I'd multiply by 1 mole over 6 times 10 to the 23rd atoms. Or molecules to moles, I multiply by 1 mole over 6 times 10 to the 23rd molecules. To convert moles to donuts, well, I thought we weren't going to do that in here. So pause the video right now and try these problems. And in a few seconds, I'll reveal the answers to you. So here's the answers written to the correct significant figures in red on the right. Make sure that you save your work and bring it in if you have trouble getting these answers, and I'll go over it with you, and we'll see if we can't figure out what's going wrong. Next, we're going to talk about converting from moles to grams or grams to moles. As you know, 1 mole is the atomic mass in grams, and that's that little decimal number you can find in the periodic table. That gives us a conversion factor of 1 mole over the atomic mass in grams, or the atomic mass in grams over 1 mole. We would use this first conversion factor to convert from grams to moles, or the second conversion factor would be used to convert from moles to grams. So let's get started. Let's convert from moles to grams. In order to do that, we would need to know that 1 mole is the atomic mass in grams. So how many grams are in 4.86 moles of copper? We want to pay attention what we're converting from and to. We're converting from moles to grams, so we need to know the mole to gram ratio. For copper, if you look at copper, the mass of copper rounded to that second decimal place is 63.55 grams. So 1 mole of copper equals 63.55 grams. Like before, we're going to write down what we're converting from first, include your units, 4.86 moles of copper, and we need to choose a conversion factor that factors out moles and gives us grams. I'll bet you've chosen the second one, because moles will factor out and we'll be left with grams, which is what we want to convert to. Now that we have that figured out, we're going to multiply 4.86 times 63.55. and that should give us 308.853 grams of copper. And by now you know too that we can't use all those numbers. Our starting value has only 3 significant figures, so we can only be certain of our third significant figure, which in this case is the 8. So we're going to look one to the right. It was another 8, and that rounds up to a 9. So our correct answer then is 309 grams of copper. So let's try converting from grams to moles. We know that 1 mole is the atomic mass in grams, so let's try this problem. How many moles are in 7.4 grams of aluminum? This problem is asking us to convert from grams to moles, so we need to know the gram to mole ratio. For aluminum, it's 1 mole of aluminum for every 26.98 grams. Again, you get the grams from looking at the atomic mass on the periodic table. We'll write down what our starting value is, what we're converting from. We need to choose a conversion factor this time that factors out grams and gives us moles. And this time it's the first conversion factor, which factors out grams and leaves us with moles, which is the goal for this problem. Grab our calculator, and this time, instead of multiplying by the molar mass, we'll be dividing by the molar mass as it's on bottom. We look at our first value, it has 2 sig figs. We're going to round to the second one. 1 to the right of 7 is a 4, so the 7 stays the same, and we're left with 0.27 moles of aluminum. So to convert from grams to moles, multiply by 1 mole over the atomic mass in grams. To convert from moles to grams, multiply by the atomic mass in grams over 1 mole, and you'll find some success. So pause the video now and do these conversions. Again, you'll need a calculator in your periodic table. Remember to round your atomic masses to 2 decimal places, and when you're done, you can move the video forward and check your answers. So here's your answers written to the correct number of significant figures. Again, save your work. If you have questions as to why you're not getting the right answers, if that's happening to you, please bring your work in and we'll go over it and see where you might be going wrong. And the last thing we're going to talk about here is two-step conversions, how to convert from grams to atoms or atoms to grams. We're going to start with grams to atoms, and the question is how many atoms are in 3.9 grams of lead. In order to solve this problem, we're going to have to do 2 conversions from grams to moles and then moles to atoms. So we'll need 2 conversion factors. If you look up the mass of lead on your periodic table, you'll find that's 207.2 grams. In this case, they only give us 1 decimal on our periodic table. And we know that 1 mole of atoms is equal to 6 times 10 to the 23rd atoms. And here we go. Write down what we're converting from. In this case, 3.9 grams of lead. And we want to get rid of grams. So we're going to put grams on bottom here. That allows us to factor out grams, and it gives us moles. And now we need to convert from moles to atoms. So we'll choose a second conversion factor that factors out moles and leaves us with atoms. And just like before when we did our previous problems, that's the atom to mole ratio. So grab your calculator and this time divide 3.9 by 207.2, and we multiply by 6.02 times 10 to the 23rd. If you do that, you'll find it equals 1.133108 and then some times 10 to the 22nd atoms of lead. 3.9 has only 2 significant figures, so we're going to look at our second sig fig. Look one to the right. It's less than 5, so our 1 stays the same, and our answer is 1.1 times 10 to the 22 atoms of lead. Let's look at converting from atoms to grams. How many grams are in 2.75 times 10 to the 25 atoms of carbon? So we need 2 conversion factors. We'll need 2 equal values. Here they are. And we're going to write down our starting value, 2.75 times 10 to the 25 atoms of carbon. We want atoms to factor out this time, and we know there are 6 times 10 to the 23 atoms in a mole. We put atoms on bottom so that atoms factor out, and that gives us moles. We have one more step to accomplish. We need to get grams from moles, so we're going to multiply by the gram to mole ratio for carbon. That's 12.01 grams per 1 mole, and this allows us to factor out moles. With our calculator, we're going to divide 2.75 times 10 to the 25 atoms by 6.02 times 10 to the 23, and then multiply times 12.01, and that will give us 548.6295 and then some grams of carbon. Our starting value has only 3 significant figures, so we can only rely on our third significant figure. Looking one to the right, you'll see that's a 6, so the 8 rounds up to a 9, and we have 549 grams of carbon. So here's some more problems for you to practice. These are all 2-step conversions. Go ahead and pause the video and try these. When you get done, as usual, you'll see the answers rounded to the correct sig figs. Here's the answers to those 2-step conversions, rounded to the correct significant figures. If you have any trouble with this, go back and watch the video again, or bring your work in and go over it with your teacher. This is Mr. Cochran, signing off.